Good morning everyone. I'm Gayatri. I'm working as Assistant Professor in Civil Engineering Department in St. Peter's Engineering College. Today I'm going to discuss about force system and resolution of force. Now first let's try and understand what is force. Force is nothing but an external energy that we apply on an object to move the object from one position to another position. Suppose this object is resting at position A. From position A, I can move this object to another position B by simply applying an external energy. This external energy is referred as force. Now, force is a vector quantity. Its unit is Newton. Now, vector quantity means it has magnitude and direction. Hence, whenever we are working with force, it is very important to know its magnitude and direction. In which direction is it moving? Now, force is of several kinds depending upon the characteristics. So, one characteristic, as I have discussed, is its magnitude. The other characteristic is its direction. Third characteristics depends upon its nature, and fourth characteristics is depending upon the point of application. So, what is nature of a force? Suppose we have an object and forces are acting in opposite direction. Then the forces tend to pull the object. When they are pulling the object, that means they are exerting a tension in the object. So this nature of the force over here becomes tensile force. It is inducing tension in this object. Now, if we take an object and the nature of the force is such that they are acting inwards towards the object, then we can call this as compressive force. They are trying to compress the object. So, depending upon the nature of the object and the forces acting on the object, we can categorize it as tensile force or compressive force. Now, moving on to point of application. Suppose we have an object. Now, the question is, where am I applying the force? If I apply force on the top of the object, then the object tends to move away from my force of application. When I'm trying to apply force at the bottom of this object, there is tendency that this object will try to move towards the direction of force. So hence it is very important to understand in which direction you are applying the force, what is the point of application of the force. As you can see, if I am applying the force at the top, it has tendency to move away. If I am applying force at the bottom, it has tendency to move towards the direction of force. So these are important characteristics of force. As I've mentioned again, force is the external energy to move an object from one position to another position. Now let's try to understand an important topic, that is system of forces. System of forces. In reality, one force doesn't act on an object. There are several forces that will be acting on it. So we need to understand, are they acting on the same plane or are they acting on different plane? For example, if I take an object, now in a 3D view, if we take an object and see that the forces are acting on one particular plane, if the forces are acting on one particular plane, so here this is our plane that we're talking about, all the forces are acting on this particular plane, then this type of force system is called as coplanar force system. Coplanar. Coplanar. That means lying on the same plane. If the forces are acting in different directions, we have one force acting here, another force acting here, and another force acting here. And as mentioned earlier, the forces acting in this direction. If we have forces acting on different planes, then this type of system is called as non-coplanar force system. This is non-coplanar. That means forces are acting on different planes. Okay. So it is very important to know whether the force is acting on a same plane or is it acting at different planes of an object. So with knowledge of this, we can move further and understand how to resolve a force or how to find a resultant of force. So what is resultant? First, let's try and understand what is resultant over here. As I mentioned, if you have an object and there are several forces acting on this object, this is called as coplanar. Now in this coplanar, all the forces are acting at one particular point. If all the forces are acting at one particular point, we call it as concurrent. Concurrent force. So now we are talking about coplanar concurrent forces. Very important for us because our next topic is completely depending on this concept. So first one has to understand what is coplanar and then what is concurrent. So coplanar is all the forces are acting on same plane and on the same plane, but their line of action can meet at a particular point, then we call it as concurrent force. Now when so many forces are acting on the object, obviously it is going to cause some kind of disturbance in the object. So the object will either, if it is in static position, will try to move, and suppose if it is in moving position, it will stop. So we have to find out the resultant of all these forces, because all these forces are acting at one particular location and then there will be one resultant force produced. This resultant force is going to give the same effect as all the individual forces are going to do on the object. So whatever is the effect of all the individual forces on the object, instead of taking individually, we find one resultant, one single force which will be acting on the object and producing same effect as the individual forces will produce. So for understanding this resultant, we need to clearly understand the nature of the force. The nature of the force is concurrent force. It is coplanar concurrent force. Then we find the resultant of that. Okay. Now resultant force, suppose as I said, there are several forces acting on an object, and due to this there is one resultant force that we need to calculate. This resultant force is also known as equivalent force, mean force, or average force. These are different terminologies used for same resultant force. Now how do we calculate a resultant force? For calculating a resultant force, we need to understand this concept that force is a vector quantity. We cannot simply add vector quantity. We need to follow some laws for vector calculation. So there are several laws for vector calculation, like triangle law, parallelogram law, polygon law. One such law that we follow is parallelogram in our concept of concurrent forces. So we will be discussing about resultant force calculation. So resultant force is calculated in several methods. One such method is parallelogram method, and the other one is method of resolution. Method of resolution is a topic that I will be covering in this video lecture in detail. To understand this method of resolution, I have given all this introduction. Now, what is parallelogram method of calculation? Parallelogram method for calculating two concurrent forces. It is its limitation also that you can calculate only two forces using this method. Suppose there are two forces, call it as F1, F2, at some angle theta, which is acting inwards. The forces are acting inwards. Now this is the situation, and we need to find resultant of such force. So resultant of such force will be somewhere here. How do I calculate resultant of this case? Now parallelogram theorem or the parallelogram method states that if we have forces acting in such a way that they form sides of a parallelogram, just imagine that this is side of a parallelogram. Okay. So if the forces are acting in such a way that they are forming sides of the parallelogram, then the resultant of these two forces, which is intersecting at some angle theta, is nothing but diagonal of the parallelogram. It is nothing but diagonal of the parallelogram. So here it is. Now this resultant is nothing but diagonal of the parallelogram. How do we calculate diagonal of a parallelogram? Now that is the basic elementary formula that we have studied earlier in our 9th and 10th class about calculation of parallelogram theorem, using parallelogram theorem calculation of a diagonal. So the diagonal is over here, R, is calculated as, if I take this force F1 as our first force, F1 square plus F2 square plus 2F1 F2 cos theta. Cos theta, where theta is the angle between the two forces. As you can see, these two forces, theta is the angle between these two forces. So this is the formula to find out the resultant in parallelogram method. This method is a quick method for calculation of resultant, but as I told you, it has limitation. The limitation is that this method is only suitable for two concurrent forces. Only two concurrent forces you can apply this formula. But what if we have more concurrent forces acting in different directions on an object? In such case, we go with method of resolution. Method of resolution is the best method to calculate the forces acting on a body and to find out the resolution. You can go with several forces acting on a body. Now, this formula that I'm talking about, this formula is actually composing the forces. You have two different forces. You have used this formula and composed it to one force. So we can also call this as composition of force. This is composition of force. In resolution of force, we are doing the opposite of this. We are taking a force and splitting it into two parts. So let's try and understand what is resolution of force. Now, in resolution of force, suppose we have a force which is inclined in this direction. Actually, the concept of revolution of force comes into picture is that this formula, as I have told you, is applicable for the forces which are only two forces which are acting at one particular point. But if we have any inclined force, we need to resolve them into their respective components, and then we need to use this formula again. So how do we resolve a force? Suppose this is a force F. Now this force F will be resolved into two components. One is along the x-axis, this is along the x-axis. The other one is along the y-axis. The resolved components will be mutually perpendicular to each other. The component that I have resolved along the x-axis, I will call it as Fx. The component that I have resolved around the y-axis, I will call it as Fy. Okay. Now let's try to understand how we find Fx and Fy. So just I'll explain it here. The force F is making an angle theta with x-axis. The force F is making an angle theta with x-axis. So in such case, this force will be resolved along the x-axis as Fx, and Fx is given as F cos theta. We are resolving this force F along the x-axis, which is making an angle theta, as F cos theta. This is along the x-axis. Now coming towards the y-axis, when we talk along the y-axis, then the force is Fy, and Fy is given as Fy is equal to F sine theta. F sine theta. Now both these forces Fx and Fy will be mutually perpendicular to each other. Now we got Fx and Fy, these are the magnitude. What about their direction? Fx and Fy are the magnitude. As I said, it is a vector quantity. We require both its direction and magnitude. Magnitude we understood using this formula. Now what about the direction? Now direction is, you have to see in which direction the force is acting. Now the force is acting inwards, so obviously the resultant force will also be acting inwards. So this is the direction of the resultant force. Okay, so whatever force we are working with, if we resolve the force into its two respective components Fx and Fy, after finding them we have to assign the correct direction to them. So if they are acting inwards, the direction will be inwards. If they are acting outwards, the direction will be outwards. For example, this is the force F which is acting outwards, making some angle theta with x-axis. Then in this situation, I will call Fx as my horizontal component. Fx is my horizontal component, and this is given as F cos theta, and this horizontal component is acting in which direction? In the outward direction. It is acting in outward direction because my force is in outward direction. So when force is in outward direction, the resultant will also be in outward direction. When force is in inward direction, resultant will also be acting inwards. So seeing upon the direction of our force, we have to understand that their respective components, horizontal and vertical components, will be in which direction. Okay, so here we have our resultant forces Fx and Fy. Now Fy calculation, as I said, it is F sin theta, Fx is equal to F cos theta with directions. Now one shouldn't think that this is a universal law, that our horizontal component is F cos theta. It is not a universal law. It only depends upon the angle the resultant is making with the respective axis. When I say that, in a simple diagram I'll explain. If my force F is acting with an angle theta with respect to y axis, and this is x axis, this is x axis, then as I said, the force will be resolved along the angle it is making with respect to that axis. So here my force F is making an angle theta with respect to y axis. So Fy over here is F cos theta. It is not F sin theta. It is F cos theta, because in previous case, as you have seen, in the previous case I have told you that whatever the angle F is making with respect to the axis, it could be x axis or y axis, with respect to the axis, whatever the angle theta this force F is making, that axis is the axis for calculating F cos theta. It is resolved along that axis. So in this case it is x axis, and in this case, because the force is inclined and making an angle theta with y axis, so our reference point over here or axis over here is y axis. So Fy is F cos theta and Fx is F sin theta. So we need to very clearly understand that the force is inclined to which axis. Is it inclined to x axis or y axis? So whichever axis the force is inclined with, corresponding to that axis, we have to resolve the force in its horizontal and vertical component. Okay, and this one is the vertical component, it is in vertical direction, and this one is the horizontal component acting in horizontal direction. Okay, now let's try and understand the sign convention for calculation of the resultant force. Now if our force is acting in the direction of x axis, that is moving away or representing x axis direction, we will take it as positive. If the force is moving in opposite direction to this, then we take it as negative. This sign convention is for horizontal direction, or we can say for horizontal component. So our horizontal components need to have a clear understanding of their directions and their sign convention. So whatever is our horizontal component after calculation, Fx and Fy, whatever is Fx value, we need to see that is this Fx positive or negative. It is positive when it is moving outwards. It is negative when it is moving inwards. So this is very important for us to understand. Now similarly, coming to the y component or the vertical component, Fy. Now in the vertical component, the sign convention is force vertically upwards is positive, force vertically downward is negative. Okay, so this is the sign convention for our vertical component. Vertical component. So one must have a clear understanding about the horizontal and vertical component resolutions how to resolve them, how to find the value of fx and fy, and how to assign a positive or negative symbol to it. So whether it is positive or negative, it depends upon the sign convention that I have explained just now. Okay, following this sign convention, we can very easily understand that the force is acting in which direction and it is along which axis. Now, this brings up to another topic, which is understanding that the force is in which quadrant. So as we know that we have 4 quadrant. This is our x-axis, y-axis. This is first quadrant. In first quadrant, the forces will be positive. That means the resolved force Fx, Fy will be positive. If we are working in second quadrant, our x-axis is negative, y-axis is positive. The forces that we get, that is the resolved forces, we have to see after using the sign convention. As I told you, upward positive, downward negative, moving away positive, moving inward negative. After following the sign convention, we have to understand what we got. If we got Fx as negative and Fy as positive, which means that it is lying in second quadrant. Now, moving to third quadrant. In third quadrant, as we know, this y is negative. X is negative, y is negative. Both the axes are negative. So after following the sign convention, if I get Fx and Fy both negative, which means that my force is lying in third quadrant. So both are negative. Okay. Now finally coming to the fourth quadrant. In fourth quadrant, as we know, x is positive, y is negative. So in fourth quadrant, our sign convention will give us an idea that x positive, y negative. X is positive, y is negative. So after understanding the forces, after resolving the forces, we need to understand that they are lying in which quadrant. Okay, so hence this will give us an complete idea of resolution of forces. Okay, now, so whenever, as I said, whenever a force is inclined with some angle theta, the force we call it as F1. If we have resolved it following the sign convention, then it is moving inwards. Obviously, it will be negative. This is moving downwards, the vertical component. This will also be negative. So this is Fx, this is Fy. They are moving inwards. Okay, this is an example to understand that how the forces can be positive or negative in nature. Now we can calculate the resultant of several forces. So this is only one force. Suppose this is a plane. Suppose we are working with several forces which are acting in different directions on a particular plane. Okay, I call these forces as F1, F2, F3. We are having 3 forces acting on a particular plane. Now we need to resolve this F1 into its components. So F1 will be resolved into its respective components as F1 cos whatever angle is given over here. Suppose this angle is given as theta 1. So this is theta 1. So this is F1 cos theta 1. As I said, the angle is very important over here. The angle is very important. Whatever is the angle theta, with that angle theta, it is making our force is resolved as F1. cos theta 1. Okay. Now, because it is inclined on x-axis, it is F1 cos theta. This is F1 sin theta 1. Okay. Now, F2, if we see F2, look at the force F2. Our force F2 is a single force which is acting in vertical direction. This force itself is making an angle 90 degree, so we don't have to resolve this force. F2 is already a vertical force. A vertical force cannot be resolved in any other component. It is already in its vertical component. An inclined force will be resolved either in horizontal or vertical component. So F2 will lie as it is. Now coming to F3, F3 making an angle theta 2. So F3 will be resolved into its respective forces, that is horizontal and vertical forces. So I'll just show here how to resolve them into their horizontal and vertical forces with the angle theta 2. So here we have F3 cos theta 2. This is the horizontal component. Direction, it is moving inwards. This is the direction, moving inwards. Here also it is moving inwards. The direction of the forces are moving inwards. Okay. Now this will be resolved and we get this as F3 sin theta 2. So this is how we are resolving the forces. Now we have several forces acting on this plane. Okay. F1 has been resolved as F1 cos theta 1, F1 sin theta 2, sorry theta 1. F2 is a force acting over here. Then F3 has been resolved into its respective components. Now so many forces are acting on the body, okay, on an object or on a plane. Now here we need to first, what we need to do is we need to take sum of all the forces that are acting in horizontal direction and sum of all the forces that are acting in vertical direction. Okay. So sum of all the forces acting in vertical and horizontal direction, I will denote it by symbol sigma h. Sum of all the forces in horizontal direction, sigma h. Okay. So what are the forces in horizontal direction? This is in horizontal direction. F1 cos theta 1. F1 cos theta 1 is in horizontal direction. What is the sign convention here? Moving inwards. Moving inwards means negative. Negative. Okay. Then what is the other force here? The other force that is acting in horizontal direction is F3 cos theta 2. F3 cos theta 2. Okay. Now these two forces are acting in the horizontal plane, in horizontal direction. Using the sign convention, I have given the first force as negative because it is moving inwards. F3 is positive. So we find out sigma h. Now we calculate sigma v. That is sum of all the vertical forces. So what are the vertical forces acting here? This is a vertical force. This is vertical. F1 sin theta 1. This is a vertical force, and what is its direction? Moving downwards. Moving downwards. Negative. Next vertical force is F2. F2 is another vertical force which is moving upwards. Moving upward means positive. Now next vertical component over here, F3 sin theta 2, moving downwards. Moving downwards, negative direction. Negative symbol will be assigned to it. Okay. So this is how we find all these forces. So many forces that are acting on an object is now resolved, and then it is segregated. Now we are calling sigma h, sigma v. Two components we have done the summation. Now what to do with the sigma h and sigma v? With this sigma h and sigma v, we are going to find out the resultant. So resultant R is equal to root over sigma h square plus sigma v square. Actually, this formula has come from the parallelogram theorem, which I have explained earlier. This parallelogram theorem. What did I explain here? That R is F1 square plus F2 square. This F1 square is now here sigma h square. F1 square is sigma h square. F2 square is sigma v square plus F1 F2 cos theta. Cos theta. The angle between sigma h and sigma v. This is sigma h, sigma v. The angle between two forces over here are 90 degree because they are mutually perpendicular to each other. So because they are mutually perpendicular to each other, cos theta is 90. This term is 0. This term doesn't exist. So therefore, our resultant is sigma h square plus sigma v square. Okay, sigma h square plus sigma v square. So this is how I get the resultant. When I use this formula, I get the resultant for several forces which are acting on a plane. Now I have resolved those forces. After resolution, using this formula, I have composed the force into one single resultant force. Now the effect of all these forces on the object is same as the effect of the force due to the resultant. It is having same effect. R is having same effect as all these components are having on the object. So this is how we resolve the force. Now here we got the magnitude. We got the magnitude. That means R value we got using the formula. R is, as I said, sigma h square plus sigma v square. We got the value of R using this formula. But what about the direction? In which direction is the resultant placed? I mean, what direction the resultant is acting? That direction is given by the formula R is equal to sigma v by sigma h. Sigma v by sigma h. How did I get that? Very simple. You just imagine again, this is the resultant R. Okay, this resultant R, I don't know this angle. This resultant R angle I want. So this angle, if I denote it by some symbol alpha, so this angle alpha of resultant is making some angle alpha with the axis, x-axis. Now this, how do I calculate? How do I find? I'll just imagine that this is a triangle. Okay. Now whatever is the value of the force over here, whatever is the value of force here, this is suppose Fy, this is Fx. So that is the value over here also, Fy. Now simple trigonometry, we can apply the formula of tan over here. So tan theta is equal to sigma, this Fy is nothing but sigma v by sigma h. So alpha over here is tan inverse of sigma v by sigma h. Okay, so this is how we get the angle that of the resultant force. The angle of the resultant force is nothing but tan inverse of sigma v by sigma h. So in this video lecture, I have explained what is a force and what are the types of forces. After understanding the type of forces, we have seen resultant. What is resultant? Calculation of resultant using method of resolution. And after finding that, we have seen that how to find the angle of the resultant. Now the last part that is left over here is this using this quadrant, understanding that where our resultant is lying. Now, as I said, you have to see here, is our sigma h positive or negative, sigma v positive or negative. If our sigma h is positive, sigma v is positive, the resultant will lie in first quadrant. And similarly, you can see here, sigma h negative, sigma v positive, second quadrant. Both are negative, third quadrant. Sigma h is positive, sigma v is negative, it lies in fourth quadrant. So that is how you can calculate the resultant, you can calculate the angle, you can calculate the direction, and also you can determine the quadrant in which it is lying. So with this, I conclude my topic, force system and resolution of forces. Thank you.